Hello, good morning. Today we're going to have our lesson, which is problem solving with trigonometry. It's 18.4, prepared by me, Ms. Salma Ahmed. Let's start. Contents of this lesson: explain 1 using the area formula, explain 2 solving right triangle, and explain 3 solving a right triangle in the coordinate plane. Let's have explain 1 using the area formula. Area formula for a triangle in terms of its side lengths. The area of triangle ABC with the sides A, B, and C can be found using the length of 2 of its sides and the sine of the included angle. So if I know side B and side C and the included angle, which is A, I'm going to use this formula to find the area, which is area equal half side B times side C sine angle A. If given side A and side C and the included angle, which is B, I'm going to change to this rule, which is area equal half side A times side C sine angle B. Or if given side A and side B and the included angle, which is C, I'm going to have this rule, which is area equal half A times B sine C. You can use any form of the area formula to find the area of a triangle, but you must have 2 side lengths and the measure of the included angle between them. Let's apply. If I have this triangle and I need to get the area for this triangle to the nearest tenth, here I have 2 sides, 3.2 meters and 4.7 meters, and the included angle 142 degrees. So I'm going directly to apply the rule by assuming that the 2 sides are A and B. So A equals 3.2 meters and B equals 4.7 meters. And the included angle is angle C, which is 142. Directly we are going to substitute in our formula. It will be half times 3.2 times 4.7 sine the included angle, which is 142. Use your calculator and round your answer to the nearest tenth. You'll find it's 4.6 meters squared. Another example. Find the area of triangle to the nearest tenth. In triangle DEF, DE equals 9 inch and DF equals 13 inch. And the measure of angle D equals 57 degrees. Sketch the triangle DEF and check that angle D is the included angle or not. So we have to sketch it and draw it. Here we are, we have DE and it is 9, and we have DF, which is 13, so they are common in the same point, which is this vertex. It will be the included angle. I'm going to directly substitute in our formula. It will be half side DE times DF sine 57 degrees. So it will be half times 9 times 13 sine 57. It gives me 49.1 inch squared to the nearest tenth. Another example. Here we have this triangle and I need to find the area. So I have these 2 sides and the included angle. So I'm going to directly substitute, which is area equal half times 12 times 15 sine 34. It gives me 50.3 millimeters squared. Another one. For the area of triangle to the nearest tenth, in triangle PQR, PQ equals 3 centimeter, QR equals 6 centimeter, and the measure of angle Q equals 108. So as we see that these 2 sides, they have the included angle, which is 108. So we can apply the rule directly. It will be area equals half PQ times QR sine Q. It will be half times 3 times 6 sine 108. Use your calculator and round your answer to the nearest tenth. It will be 8.6 centimeters squared. Explain 2 solving right triangle. To solve a right triangle, it means you have to find the length of all its sides and the measure of all its angles. To solve a right triangle, you need to know either 2 sides length or one side length and an acute angle measure. Based on the given information, choose among trigonometric ratios, inverse trigonometric ratios, and the Pythagorean theorem to help you solve the right triangle. Let's apply. If I have a shelf extend perpendicularly 7-inch from a wall, you want to place 9-inch brace under the shelf, as shown. To the nearest tenth of an inch, how far below the shelf will the brace be attached to the wall? To the nearest degree, what angle will the brace make the shelf with the shelf and with the wall? So here we have to get the BC, and this is the shelf, which is AC, and this is the brace, which is AB. So I have, this is 9 and this is 7, and I need to find the third side. Then I need to find these two angles, angle A and angle B. We are going to start to get BC. By Pythagorean theorem, we can use AC squared plus BC squared equal AB squared. So it will be 7 squared plus BC squared equals 9 squared. I'm going to isolate BC in one side, so it will be BC squared equal 9 squared minus 7 squared. It gives me 81 minus 49, give me 32. To get BC, only one BC, so we are going to take a square root for both sides. It will be root 32, which is approximately 5.7 inch. Now we are going to move to get the two angles, measure of angle A and measure of angle B. So I'm going to choose this relation, which is I'm going to use cosine angle A to give me adjacent over hypotenuse. So here it will be 7/9. To get measure of angle A, it will be inverse cosine 7/9, which is by calculator, it will be 39 degrees to the nearest degree. Now I need to find measure of angle B. So what's the relation between A and B? They are, yes, complementary angles. So I'm going to use measure of angle B is equal 90 minus measure of angle A, as if they are complementary angles. So it will be 90 minus 39, and it gives me 51 degrees. Let's have another example. A building casts a 33-meter shadow when the sun is at an angle of 27 degrees to the vertical. How tall is the building to the nearest meter? How far it is from the top of the building to the tip of the shadow? What angle does a ray from the sun along the edge of the shadow make with the ground? So here we have to find how tall of the building, which is EF, and we need to find DF. As we find the three sides, and then we are going to move to find the missing angles. So here we are going to choose the trigonometric ratio for angle F, which is 10. It will be opposite over adjacent, so it will be 33 over EF. Then I'm going to isolate EF in one side and get tan 27 under in the denominator to be 33 over tan 27. By using your calculator, you will find that it's 65 meters, which is to the nearest meter. Let's move and continue. We are going now to get DF. So DF is an hypotenuse. I'm not going to use Pythagorean theorem. He's asking me to use another trigonometric ratio. So here we are going to find sine F. It gives me opposite over hypotenuse. So it will be DE over DF. DE is 33 and DF we need to find it. I'm going to isolate DF in one side and get sine 27 in the other side in the denominator. By using your calculator, we will find it's 73 meters squared. Now we are going to move to find the missing angle, as if this is 90 and this is 27, so we need to find measure of angle D. By the complementary angles, because D and F are complementary angles, we can find it, and measure of angle D is equal 90 minus 27 to get the answer of measure of angle D. Here we are, so measure of angle D equals 90 minus 27, and it gives me 63 degrees. Explain 3. Solving a right triangle in the coordinate plane. You can use the distance formula as well as trigonometric tools to solve right triangles in the coordinate plane. Let's have this example. Solve the triangle, find the sides length of the to the nearest hundredth and the angle measures to the nearest degree. Here we have our triangle, but it's given as a vertices. Vertex A, which is -3 and 3, vertex B, which is -3 and -1, and vertex C, which is 4 and -1. So we need to plot this to find out our triangle. So if I'm going to plot, it will be -3 and 3. I'm going to move to the left and -3, and then going up to 3. So this will be point A. Then I'm going to plot -3 and -1. So it will be -3 to the left and then -1 down. So it will be point B. Then I'm going to plot the third one, which is 4 and -1. It will be C. Now I'm going to connect these points. So AB, when I connect them, I found that the length of this side, it's 4 units or 4 squares. So this will be 4. Now I'm going to connect BC, and I found when I count the squares, it's 7 units. So I know now these two sides. I have to find the third side, which is AC. So I'm going to, after plotting the points, we found that in AB equals 4, BC equals 7. So we are going to use distance formula to find the distance between A and C. So I'm going to assume that A is 0.1, which is x1, y1, and I'm going to assume point C as if it's 0.2, which is x2, y2. Let's apply that rule, which is the distance formula. It is root x2 minus x1 all squared plus y2 minus y1 all squared. I'm going to substitute by x and y from these 2 points that I have. So it will be 4 minus -3 all squared, then -1 minus 3 all squared. So here we are. After using your calculators, you can find it is root 65. And it will be 8.06 to the nearest hundredth. Now we are going to have the other side of the triangle to solve it. So we need to find the angles of this triangle. So we are going to continue. AB is perpendicular to BC, so measure of angle B is 90. Now we have to find angle A and we have to find angle C. We use the inverse tan ratio to find measure of angle C, as if it is opposite over adjacent. So it will be measure of angle C is equal inverse tan AB over BC. So it is inverse tan 4 over 7. Use your calculator, you'll find measure of angle C is equal 30 degrees. Now we are going to have measure of angle A. Angle A and angle C are complementary angles, so I can use measure of angle A is approximately equals 90 minus 30 to give me 60 degrees. For more practice, you are able to answer page 974 all and page 975 number 6 only. Thanks for watching, and if you have any question, just contact me. Thank you very much.